Imagine you have a stone. You drop it. It falls. Why? Because objects with mass attract other objects with mass. That attraction is what we call gravity. So far, nothing mysterious. Now take the same stone, but imagine adding more and more mass to it. As the mass increases, the gravitational pull becomes stronger. Add even more mass packed into the same small space, and gravity becomes extremely strong. Keep going. At a certain point, the gravity becomes so intense that even light cannot escape, and that quite simply is a black hole. Let's clear up the biggest misunderstanding right away. A black hole is not a hole. It is not a tunnel. It is not a cosmic drain. It is not a doorway to somewhere else. The word hole is actually very misleading. In physics, a black hole is not an empty place. It is the exact opposite. It is a place where too much mass is packed into too little space. Think about gravity in everyday life. The earth pulls you down because it has mass. The sun pulls the earth because it has more mass. Nothing mysterious, just mass attracting mass. Now imagine taking a star, something already millions of times heavier than the earth, and squeezing it smaller and smaller. As the size shrinks, the gravity gets stronger. Not because gravity turns evil, but because all that mass is now concentrated. At some point, the concentration becomes so extreme that something remarkable happens. The structure of space and time itself changes. This is where physics becomes very careful with words. Physics does not say objects are sucked in. Physics says space and time are curved so strongly that all paths lead inward. That's a completely different idea. Nothing is being dragged, nothing is being grabbed. If you move forward in time near a black hole, the geometry of space, time forces your future to point inward. It's not a pull, it's a direction. Imagine standing on the surface of the earth. You don't feel a force pulling you down through the planet. You simply follow the shape of space-time around Earth. A black hole is the same idea, but taken to an extreme. Space is curved so deeply that once you pass a certain point, there is no outward direction left. Every possible future points toward the center. That's why light cannot escape. Not because light slows down, not because it runs out of energy, but because there is no path leading outward. Calling this a hole makes people imagine emptiness. But a black hole is not empty. It contains mass, energy, and structure. In fact, from far away, a black hole behaves just like any other object with the same mass. If the sun were magically replaced by a black hole of equal mass, the Earth would continue orbiting almost exactly the same way. Nothing would suddenly get sucked in. Gravity doesn't change, only the shape of space very close to the center does. So why does the name stick? Because when light can't escape, we see darkness. And the human mind fills darkness with mystery. But physics doesn't care about mystery. Physics asks one question. What do the equations actually say? And the equations say this. It is a place where space and time themselves are bent extremely bent. And once you understand that, everything else suddenly makes sense. Let's start with gravity. In everyday language, we say gravity is a force that pulls things down. But in modern physics, that's not the real picture. Gravity is not a rope. It is not an invisible hand pulling objects. According to Einstein, gravity is the result of curved space-time. Mass tells space-time how to curve. Curved space-time tells objects how to move. That's it. Think about Earth. You feel pulled downward, but nothing is actually yanking you. You are simply following the natural shape of space-time around the Earth. If Earth suddenly disappeared, the downward pull would disappear too, because the curvature would be gone. So gravity is geometry, not force. Geometry. Now take this idea and push it to the extreme. Imagine a massive star collapsing under its own weight. The mass doesn't vanish. It gets compressed into a smaller and smaller region. As that happens, the curvature of space-time becomes steeper and steeper, like stretching a rubber sheet further and further downward. At some point, the curve becomes so deep that every possible path points inward. This is the crucial idea. Nothing is being dragged. Nothing is being sucked in. There is simply no outward direction left. This is why a black hole is not a hole. A hole suggests emptiness. A black hole is not empty at all. It is a region where space-time is curved so strongly that once you cross a certain boundary, your future in time leads inevitably toward the center. Even standing still won't help. Because standing still no longer exists as an option. Light behaves the same way. People often say, light can't escape because gravity is too strong. That's not quite right. Light always moves at the same speed. It never slows down. The real reason light cannot escape is simpler and stranger. There is no path through space-time that leads outward. Light isn't weak. It isn't trapped. It just follows the geometry, and the geometry leads inward. This is where the idea of a hole completely fails. A hole is something you could go around, but curved space-time is not something you fall into. It is something you are already inside of. From the outside, nothing looks special. A black hole behaves just like any other object with the same mass. Only when you get very close does the curvature dominate everything. In the Feynman spirit, the lesson is this: don't add drama where geometry is enough. Nature isn't malicious. It isn't trying to trap things. It is simply following its own rules, and those rules say that mass curves space. Time. A black hole is just the most extreme example of that rule. No holes, no tunnels, no science fiction monsters. Just space and time bent until every road points one way. There is a line around a black hole that people talk about with a lot of drama. They imagine a wall, a surface, a glowing boundary you crash into. That picture is wrong. The event horizon is not a wall. It is not a surface you can touch. It is not even something special that happens to you at that moment. The event horizon is simply a boundary in space-time, and what it separates is not space, but possible futures. Let's slow down and be precise. In everyday life, you always have options. You can move left or right, forward or backward. You can stop. You can turn around. Physics describes all of these as paths through space and time. Now imagine space-time becoming more and more curved as it does near a black hole. The stronger the curvature, the more those paths tilt inward. At first, you can still escape if you try hard enough. But then comes a point where something fundamental changes. At the event horizon, there are no outward paths left. None. Not for rockets, not for light, not for signals, not even in principle. This is not because engines fail. It's not because gravity suddenly spikes. It's because the geometry of space-time itself no longer allows an outside future. That's why the name is so precise. An event horizon is the boundary beyond which events can no longer affect the outside universe. Here is the most important idea, and it sounds strange at first. Crossing the event horizon is not a spatial mistake. It is a temporal one. Once you cross it, going inward is no longer a choice. It becomes as unavoidable as moving into tomorrow. You cannot choose to stop time. And inside the event horizon, you cannot choose not to move toward the center. The center lies in your future, the same way next Tuesday lies in your future. This is why the event horizon is not dramatic from the inside. If the black hole is large enough, you could cross it without noticing anything special at all. No flash, no shock, no invisible wall. Physics doesn't announce it. The only thing that changes is something you cannot feel, the structure of your possible futures. From the outside, however, things look very different. An observer far away never actually sees you cross the event horizon. Your signals arrive slower and slower. Your clock appears to tick more and more slowly. Not because time is broken, but because time is curved. Eventually, your image fades. From the outside perspective, you never quite make it. Both descriptions are correct. And that's not philosophy, that's physics. So why can't information escape? Because to escape would require moving into a future that no longer exists. The event horizon is not a prison wall. It is a one-way boundary in time. Outside the horizon, the future includes infinity. Inside the horizon, the future ends at the center. That's it. no force fields, no cosmic barriers, just geometry. This is very much the Feynman way of thinking. When something sounds mysterious, ask what changes precisely. At the event horizon, nothing magical happens to matter. What changes is the set of allowed paths through space-time. And once those paths all point inward, returning is not forbidden. It is simply not defined. So the clean, honest statement is this: the event horizon is the line beyond which outside is no longer part of the future. From the outside, nothing special to see. From the inside, every tomorrow leads inward. And that is why the event horizon is truly the point of no return. At the very center of a black hole, physics gives us a word not because we understand what's there, but because we don't. That word is singularity. And it's important to say this immediately. A singularity is not something physics explains. It is something physics admits it cannot explain. Let's be careful. When physicists say singularity, they are not describing an object. They are describing a failure of our equations. The math says that certain quantities blow up. Mass density infinite, curvature of space-time infinite, gravity infinite. And whenever you see infinity appear in a physical theory, that is a warning sign. It means this theory has gone beyond where it can be trusted. People often imagine the singularity as a tiny dot or a point of infinite mass. That image is misleading. Physics does not tell us what the singularity is. Physics only tells us that our current descriptions stop working there. So the honest statement is not, the singularity has infinite density. The honest statement is, our equations predict infinity, which means they are no longer describing reality correctly. This is very much the Feynman attitude. Feynman never trusted equations blindly. He trusted what they could successfully explain, and he was equally serious about where they failed. He would say something like, if your equations give nonsense, it's not because nature is nonsense, it's because you're asking the wrong questions with incomplete tools. Why does the singularity appear at all? Because we are using general relativity, a theory that treats space-time as smooth and continuous, but we are also squeezing matter into an unimaginably tiny region. At that scale, we expect quantum effects to matter. And here is the problem. General relativity ignores quantum mechanics. Quantum mechanics ignores gravity. At the singularity, both are needed, and we don't yet have a theory that combines them correctly. So physics doesn't explode. Our framework does. Think of it like this. If you try to use Newton's laws to describe atoms, you get nonsense. Not because atoms are impossible, but because Newton's laws were never meant for that scale. The singularity is the same kind of message. Nature is telling us, your current language is insufficient here. So when people ask, what happens at the singularity, the most accurate answer in physics is, we don't know. Not it's mysterious, not it's supernatural. Just, we do not yet have the right theory. And that's not a weakness, that's how science progresses. What we do know is this: the singularity is not something you could observe. It is hidden behind the event horizon. No signal from it reaches us. No measurement can directly test it. All we see are the effects outside, and those effects are described perfectly well by existing physics. The silence is only at the center. So the phrase where physics falls silent doesn't mean physics gives up. It means physics is being honest. It means physics is saying, up to here, our understanding works. Beyond this, we must learn something new. That is not failure. That is an invitation. And this is the deepest lesson, very much in the Feynman spirit. A singularity is not a thing in nature. It is a signpost. It points to the edge of knowledge. Whenever physics reaches a singularity, it is not the end of understanding. It is the beginning of the next question. After stripping away all the drama, all the metaphors, and all the science fiction language, we are left with something surprisingly simple. A black hole is not a monster. It is not evil. It is not hungry. Nature does not build monsters. Nature follows rules. A black hole does not pull things in with some mysterious supernatural power. There is no secret force, no cosmic vacuum, no intention. What we call a black hole is simply the natural consequence of gravity when gravity is pushed to its extreme limit. That's all. Gravity, at its heart, is very honest. Mass curves space and time. Objects follow that curvature. Most of the time, the curvature is gentle. Planets orbit. Apples fall. Light bends slightly, nothing strange. But if you compress enough mass into a small enough region, the curvature becomes severe. So severe that space has no outward directions left. Not because space breaks, but because the geometry itself closes in. This is where people panic unnecessarily. Physics does not panic. Physics doesn't say, "This is terrifying." Physics says, "This is interesting." A black hole is not a violation of the laws of physics. It is the laws of physics working exactly as written, all the way to their edge. And when physics reaches that edge, something important happens. Not fear, not confusion, honesty. Physics looks at the equations and says, up to here, we understand. And beyond this point, we don't. That is not weakness. That is scientific strength. When we talk about the event horizon, the singularity, the bending of time, none of these are signs that nature has gone wrong. They are signs that our current descriptions are incomplete. Feynman loved this idea. He never believed physics was about having final answers. He believed physics was about knowing exactly where your understanding stops. If you don't know where it stops, you don't really understand anything at all. So here's the clean conclusion. Without mythology, a black hole is not a demon. It does not suck the universe inward. It does not break physics. It simply shows us what gravity does when there is nowhere left to compromise. Physics is not afraid of black holes. Physics treats them the same way it treats everything else in nature, by asking precise questions and accepting precise limits. And when physics says, "Here, we must learn more," that is not surrender. That is curiosity doing its job. So the most Feynman-like statement you can make about black holes is this. A black hole is not a failure of nature. It is a reminder that understanding is always a work in progress. And that is exactly how science is supposed to work.